The third type of normal distribution problem that we can have is a between type of problem. So again, we're starting with the same data, talking about blood cholesterol of these 14-year-old boys. Tells us it has a mean of 170 and a standard deviation of 30. This time the question says, what proportion of boys have cholesterol levels between 150 and 240? So let's start by drawing a little picture of what this looks like. So I'm sketching out my normal distribution here. Has a mean of 170, and I can mark off the distances of 1, 2, and 3 standard deviations from the mean. And if you don't know where I'm getting these numbers from, watch the first video because I explained it a little bit more detailed in that one. Okay, so we want to know between 150 and 240. So 150 is about right here. 240 is about right here. And I'm looking for the between area, which is all this shaded part between those two lines. So thinking about table A always gives us the percentile, which is the area to the left of our value. So in order to find a between area like this, our strategy is going to be this. First, we're going to find the area to the left, all the way to the left, of 240. That's what the table will give us. Then we're going to find the area to the left of 150. If we take that big area and we subtract off the little area less than 150, that's going to leave us with this between area right here, which will be the answer to our question. So we're going to end up finding two z-scores and finding two different areas because we have two different x values that were given in the problem. So let's start with the bigger one. We're going to find standardize or find the z-score for 240. And if you recall, when we find the z-score, we take the x value minus the mean and divide it by the standard deviation. So this should look a little bit familiar because it's the same x value that we looked at in the first problem. We end up with a z-score of 2.33. Once we have our z-score, we can go on over to table A and look up the area to the left. So here's our snippet of table A. I'm looking on the part of the table that has positive z-scores. And remember, our z was 2.33. So I'm going to look up 2.3 on the left column over here. I'm going to look at the 03 column right here that goes with the hundredths place. And my value from the table, that area, is going to be 0.9901. So from table A, I'm going to write 0.9901. Okay, now I'm going to go through the same process with my other x value, the 150. So z is going to be equal to 150 minus the mean of 170 divided by the standard deviation of 30. So that's going to be equal to negative 0.67. Again, I'm going to head over to table A. This time I have to look at the part of the table that has negative z-scores. So here you can see all these z-scores on the left-hand column. They're all negative. And just for reference, the z that I'm looking up is negative 0.67. So on this side, I'm going to look at this negative 0.6. And the hundredths place has a 7, so I'm going to look at the 07 column. And where those two intersect right here is the area that I'm looking for. So that 0.2514 is the number I need. So back here I'll write down that 0.2514. Now I'm just going to take that big area and subtract off the little area. So I'm going to subtract those. So I'm getting out my handy dandy calculator on my end. Hopefully you're doing the same thing on yours. If I take 0.9901 and I subtract 0.2514, then I get 0.7387. And that's my answer. Okay, so that tells us that between area right in there, 0.7 Really, that is a 7. 3, 8, 7. So all I need to do is write a sentence stating my conclusion. So the proportion of boys with cholesterol between 150 and 240 is 0.7387 or 73.87%. And that's it.